Log equations. Oh, I love log equations. Well, the first kind actually, kind of looks like the simplifying ones we did, if they give you that, just your basic ones. If you get it out of logarithmic form, it makes it super easy to solve. 4 to what power equals 16? Of course, you know x is 2. Let's say they put the x in the base position. X cubed equals 27, so what's x? Yep, 3. Or let's say they put x here. We'll throw in a negative just to keep things spicy. 5 to the negative 2 power equals x. So squared, negative exponent, under 1. So you can have them in the basic positions, but more often than not, you're going to have it in by using your law of logs, which is not bad. Sometimes they look horrendous, but they're actually quite nice. Now we'll start off with logs on both sides. I will say 20. If I had something like this, now if logs are on both sides, like let me jump ahead a second. Let me go over here, then come back to this. If I had log 4 of 5x equals log 4 of 30, if you have logs of the same index, the same base on both sides, it's like you can cancel them and focus only on what you're taking the log of. So if 5x equals 30, x is 6. Now the only thing you have to worry about is you can never take the log of a negative number. So you can never, like if the answer, you can never take the log of a negative. And the reason is, actually we could go by graphing, and the domain, I'll flip this back real quick of a basic one. Remember, domain is x is greater than 0. So that's why you can never take the log of a negative number, because your graph didn't go over there. Well, anyway, so there you go. So x is 6. Well, let's say we have, going back to this one, if we get to the point that logs are on both sides, we can cancel it and everything's great. But I have 2 logs on the left. Ha-ha. But I am adding them, so if I want to condense them into 1, when you add, that's the same thing as multiply. So then, logs cancel. 5x equals 20. X is 4. Just like if I had log 6 of x minus log 6 of, 8 equals log 6 of 3. Condense the left-hand side. So log 6 of x, over 8. Log 6, 3. Logs cancel. So if I have x over 8 equals 3, 24. Okay, let's say if I had 2 log 8 of x equals log 8 of 49. Well, in that case, remember x or coefficients become exponents. So what I really have is this. So now, logs on both sides, x squared equals 49. So technically 7 and negative 7, but remember right here in the original, you can't take the log of a negative number, so it's only 7. Okay, let's say that I give you this. What do we want? Maybe log 3 of x plus 7 equals 9. Now, something like this, I know you're like, whoa. Well, think about if this was just x, what would you do? Yeah, subtract the 7. So let's subtract the 7. So we get log base 3 of x equals 2. Well, notice how x is not just 2 because logs are not on both sides. If logs are not on both sides, that means we cannot just cancel them. But what do you know from the very beginning? If logs are only on one side, you can circle. So 3 squared equals x. X is 9. So if logs are only on one side, if you need to, you can condense them. But let's say x 8 like this. Logs are only on one side. So you can start off by condensing them, add, so multiply, but you can't just drop it because this side doesn't have a log. So if logs are only on one side, always circle. So 4 squared, 16 equals 8x. X is 2. Let's do one more at least. Let's say this one. And I know you're like, ooh, a half. Well, coefficients become exponents. So, that was not what I wanted. Let's change that to a smaller number. We'll say 2, and you'll see why in a second. So what I really have is log base 5 x to the 1/2 equals 2. So 5 squared equals x to the 1/2. And how can you get rid of a 1/2 power or square root? You square it. So 5 squared or 25 squared, 625. Now one like this also could look like this. Let's say cube root of x equals, I don't know, not equals there, 5. So notice how logs are on both sides of this one, so they can cancel. Actually, that would have had a 1/3 out front to begin with. But anyway, it's all right. So cube root of x equals 5. Cube both sides. 125. You can also solve with natural logs. It works out the same way. Natural log of x plus natural log of, 11 equals natural log of 33. It's the same thing. Natural log of 11x equals natural log of 33. Logs are on both sides. X is 3. So it's the same exact formulas. Now, of course, yes, they can get messier if it's only natural log on one side. Typically, they don't do that with those, but it would work the same way, except it would be log base e. But I'll save the messy ones for another day. I hope this was of help to you as always. Have a great day.